Okay, folks, we'll be talking about solution stoichiometry today. Now, solution stoichiometry basically deals with the concentrations of solutions, right? You see over here, the concentration of solutions. Now, when we look at a solution, right, there are a few things that a solution is made up of. The first thing is called a solute, the other one is called a solvent, and the last one is called a solution. Okay, now a solute dissolves in a solvent to form a solution. All right, that's basically it, right? So let me explain this to you a little bit further. Let's find some space. Okay, now let's say you have that's the same color. Okay, let's say you have 17.855 grams of sodium chloride. Okay, and then what you do is you dissolve this entire thing in, let's say, 475 milliliters of water. Okay, water. So at the end of the day, you get a solution. You get something here. This is, we call this saline. Let's say, call this saline. Okay. So as far as we are concerned, we have the sodium chloride dissolved in water. We get this mixture. So this is what we call solute. Solute is the stuff that you dissolve. Solvent, water, is what we call solvent here. Solvent is the solution that we are using to dissolve the solute, and the mixture of the solute and the solvent is called solution. Okay, so this is what we call solution. So in this chapter, what we want to do is we want to work out the concentration of the saline solution. What is the concentration of the saline solution? So the concentration of saline solution can be expressed in a few ways, okay? In a few ways. So one way is this thing called percentage weight over weight, okay? Gram over gram. Percentage weight over volume, gram over ml. That's one. Another way of doing this is called molarity. Okay, it's called molarity. As a chemistry student, most of the time we express concentrations as molarity, but here I will show you how to do all these three things. So percentage weight by weight, percentage weight by volume, these are ways which allows even non-chemistry students to understand concentration. Okay, so I'm going to show you all the three ways that we can do this, right? So let's do percentage weight over volume first. So it's the mass of the solute divided with the volume of the solution times 100. This 100 is basically percentage, yeah? So what we're going to do here is, if you look at this question here, so quite simply what we're going to do is we're going to take 17.855 gram divided with 475 ml, and we're going to multiply this with 100%. So this will give us, okay, 17.855 divided with 475 times 100. So this will give us 3.76% weight over volume. Okay, so sometimes you might see in some books it's written as this percentage m over v. M basically is mass over volume. It's the same concept. Okay, same concept. So one thing I want to highlight here for you is, if the top unit here is in grams, the bottom unit is in ml. But if the top unit is in kilograms, then the bottom unit will be in liters. Okay, so gram and ml, kilogram and liter. That's how it goes. Then let's look at the next one. So the next one here was percentage weight over weight. Okay, mass of solute divided with mass of solution. Now in this case, what we need to do is we need to make an assumption. The assumption that we're going to make is 475 ml water is the same as 475 grams, okay? Because the assumption that we are making is that 1 ml of water is the same as 1 gram of water. So we're going to make an assumption. So when we do this calculation now, what we're going to do is we're going to say, hey, so the mass of the solute, which was 17.855 grams, divided with the mass of the solution. Now the mass of the solution now is going to be 475 plus the mass of the solute. Okay, that's going to be the mass of the solution, and you multiply this with 100%. And so this is going to be 17.855 divided with 475 plus 17.855 times 100. This is going to be 3.62%, okay, weight over weight. So it's slightly different, okay, slightly different. So the difference now is that we have added the mass of the solute in our solution. Again, I would like to highlight to you, if the top is gram, the bottom here is in gram. So if the top was in kilogram, then the bottom here will be in kilogram. Okay. Then the next thing that we can do is we can calculate this as how chemistry students are supposed to calculate this. So in chemistry, we express concentration as molarity. Molarity has a unit, capital M. Capital M is called molar. Okay, it's molar. And molar has a unit. Okay, the unit for molar is either capital M or mole per liter or mole per dm cube. Now here I would like to tell you 1 liter is the same as decimeter cube. It's the same. Liter and decimeter cube is the same, just like milliliter is the same as centimeter cube. Right? And the conversion factor is, let's say for example, if you want to convert milliliter to liter, we divide this with 1,000. Okay. In the same way, if you want to convert centimeter cube into decimeter cube, you have to divide with 1,000. Same thing. Okay. So what we're going to do is now for this particular question, we are going to calculate the molarity. So molarity is given to us by a formula which is mole of solute, and we divide this with the volume of solution. But the volume of the solution has to be in liter. Okay, liter or decimeter cube. Okay, so let's do this. So the step number one is the volume. The volume here is 475. What we're going to do is we're going to divide this with 1,000, and you get 0.475 liters. What we're going to do here is we're going to find the moles of these solutes. So the molar mass of sodium chloride, I know, is 58.5 grams per mole. So I'm going to take 17.855 divided with 58.5. This will give us, oops, I think I did a mistake. 17.855 divided with 58.5. One second, yeah. 17.855 divided with 58.5. Something's wrong with the calculator. 1 second. Okay, sorry. Okay, so something was going on with the calculator. 0.3052 moles. Okay, all right. So what happens now is, what we're going to do is we're going to take these two values. We're going to take these two values here. So molarity will be the moles 0.3052 divided with 0.475, and this will give us 0.6426 capital M molar. And how many significant numbers? Okay, so my volume was in 3 significant numbers, so my answer should have been actually 0.6 0.643 molar. I can write it as this, or I can write it as 0.643 mole per liter. Okay, or I can write it as 0.4. Still getting used to these things. Okay, 0.643 mole per dm cube. Okay, same thing. All right, so that's the first part here. Then so basically the formula that you're going to remember is this. Okay, so mole will be molarity times volume. Okay, because if you remember earlier, what we did was we took molarity and we took moles divided with volume. Okay, so now that's how this formula comes out. So which means that now we have come across a few formulas. The first formula that we have come across is mole equals to mass over the molar mass. Then we have mole, number of particles, divided with number of the Avogadro's constant. And now we have moles equals to molarity times volume. So the only thing here is, must remember, the volume must be in liter or decimeter cube. Okay, all right. So that brings us to the next part. The next part talks about dilution. So let's say the concentration of the solution we had just now was 0. Okay, so let's say there is a solution here we just prepared just now. This was 0.643 molar. Okay, now let's say you are given a solution. Okay, you're given a solution, and this solution has a concentration of let's say 3.52 molar. Okay, it has a concentration of 3.52 molar, and you have been asked to prepare let's say 375 ml of 0.643 molar sodium chloride. Okay, using 3.52 ml sodium chloride as a starting material. Okay, so that's what you need to do, right? So what we're going to do is, quite simply, we're going to use a formula. Where's the formula? Okay, the formula is here. You can see it here. Now, for those of you who have done IGCSE, this is the formula that you are familiar with. For those of you who did SPM, the formula will be M1, V1, M2, V2. Okay, initial molarity, initial volume, final molarity, final volume, or initial concentration, initial volume, final concentration, final volume. So let's look at this question here. So let's identify which is which. So this is the initial concentration. So this is what is given to us initially. So this would be M1 or C1. We are expected to work this out. This is what we have been asked to work out. So this becomes M2. And we want to prepare 375 ml of this. So this would be V2. So the final volume that we are expecting is 375, and the concentration should be 0.642. And so what we're going to do is we're going to quite simply use this formula, M1 V1 equals to M2 V2, right? So let's plug this in. 3.52 times V1, which we don't know, equals to 0.642 times 375. Let's do this. So V1 will be V1 will be 68.45 ml. That's what it will be. Okay, so what does this mean? What does this mean to us? It basically means you take 68.45 ml of 3.52 molar sodium chloride. You take that, and then you add 375 minus 68.45 ml of water. Okay, so what you're going to do is you're basically what you're going to do is you're going to have this. Okay, so 68.45 ml will be your sodium chloride, the original sodium chloride, and then the rest of it is going to be water. So the total volume here should be 375 ml. That's what it's supposed to be. Okay, all right. So then the rest of it here will be quite straightforward as well for you to do. Okay, so we'll stop here.